Good morning, students. How are you today? And let me ask you a short question. What did you have for breakfast? Only milk. That's why the good morning was too low today. Good morning, students.
Good morning, madam.
Good morning. Okay, now it's loud enough. And milk for breakfast? Not a good thing. Okay, Michelle? Next time we should have food during the morning. Okay, so welcome to another class, yet another day for maths. And what are we going to study today? Anyone has any idea?
Probabilities.
Probabilities. Yes, we are down to probability and we're down to statistics now, right? We just left with probability, differentiation and integration to cover. And today, this week, we have started off with probability, and today we will be covering more concepts of probability. It's just the introductory class because we are time bound. There is an assembly later on in the afternoon, so we have to focus on just little concepts today. Sorry about that, but yes, the assembly is also important because there are some disciplinary issues in the school at the moment. So because of that, the class will be just for 20 minutes. Now, let's start off with the class. Should I share something motivational with you? Yes, I should. So I read a quote today, this morning. And the quote was that, the amount of energy and effort we take in being negative, in thinking and regretting that this is actually not going to happen, I shouldn't have done that, is the equal amount of energy you can take and put it into be positive. Many a times, we are quite negative about situations. I'm pretty sure when the day starts, sometimes we don't feel good about it. You feel like, oh, why did the day start? Even before your maths class, I'm pretty sure you had that idea. Oh no, I'll go back to the teacher, I'll have to see your face again. Why is this happening? Again, another bulk of maths in my head. But dear students, remember one thing. The amount of energy, like I said, the amount of time we take out just to think that this cannot be possible, why are we doing this? This is basically just impossible for me, is the equal amount of energy you can take to be positive and to hope that something good will happen at the end. So that's a message for you today. And also, very soon we'll be coming into the short test. We'll be going over mini exams and you're year 13. You'll be sitting for your final exam. And our main focus is that before you go and sit for your final exam, you have a basic idea of what is happening in maths. Right? Your aim should not be to get 100% or to get 100 out of 100. Your aim should be to put that 100% there. Your effort should be 100%. And I'm pretty sure if you put it 100%, you'll get at least a good outcome from there. You can get 90, you can get 80, you can get 70, and even you can get 100. But sometimes we feel like, okay, I have placed in this much effort, I didn't get the result. That was seen in your media exams. Most of you were very disheartened, right? Michelle, you did a very good job in your media exam, so good on that. But most of you must be wondering, oh, I didn't do a good job. Why is it like that? I was also a student, dear students. I also had experienced what you are experiencing now. I also had many exams which weren't good. That doesn't mean that you lose hope. And that's the motivation for today. Motivational quote on a Friday. To hope and to be positive. Let's start off with our class for today. We will jump into statistics and we'll try to understand what is statistics. And then from there, let's derive probability. Now, I want some responses from the room. What does statistics mean to you? Let's brainstorm, right? How would you define statistics? Or why do you think statistics is important? You have done this in year 12 and also in year 11. This has been a concept introduced to you. There are certain concepts in the statistics that we'll cover which will not be useful. You have already covered it during your year 10 and year 9 classes. Probability has always been there. But why do you think this is so important? How do you think this is related to our life? Any responses? I'll give you 2 minutes to think. Don't stress, just think about it. Think about where do you see statistics? What is statistics?
Use of facts.
Use of facts, right? Use of facts. And why do you think we need use of facts? Or where do we get statistics? Why, when we said it's facts, why do we need to know facts?
Information used in service. Like the number of people.
Right, number of people, number of good job there. What else do you think? How about news? Do you think statistics is there in news? How is it there in news? Do you watch the MT1 news daily? I'm pretty sure you're not. Because that is one place where students don't want to go, right? But it is important to watch the news. Do you read the newspaper? Do you wake up early morning and see what will the weather be like today? Prediction. Statistics comes with prediction. When you're trying to predict something. And to predict something, you need facts, you need people to be involved, and that prediction can be related to other people through news. And news always, okay, today, your task, go back and watch the 6 p.m. news, either at MT1 or the FBC news that's at 7. Watch that news and watch it till the end. You will see there are numbers, there are data that they will be released. Always towards the end of the news, you'll see, they'll say what is the rate of commodity, right? What is the value of gold now? What is the value of fuel now? That is basic application of statistics. Wherever you hear about percentage, when you hear about rate, when you hear about average, mean, when you hear about, what are other words associated with statistics? Mode. What about range? And one more thing. Mean, median, and mode. You have range. Interquartile range. Very good. So there are so many words that describe statistics. And like Shani has said, statistics is important for our life. So that we know what is actually happening around. It gives you a factual data. So with statistics, one word that you always know is data. And what is data? Not the data in your phone that you actually use to watch YouTube. What is data? Data in terms of this.
Information collected from the.
Yes, go ahead. Perfect, you're right. Good boy. That is actually right. Information that is collected. Very good. Now that was quick brainstorming of statistics. We said, how is statistics important in life?
Survey purposes.
Survey purposes, very good. What else? Let's say you're not working, right? Or there is a family, or there is a woman, or there is a man who is elderly, they're at home, they're not working. Why would they need statistics? Why would they need to know what's happening around them? Remember, sometimes I give answers in the question. Why would a person at home want to know what's in the news? Why would a person at home who is retired need to know this basic idea of statistics? How data works, how average works, how range works, how percentage works.
Is it applied in our daily lives?
Yes, it is applied in our daily lives. And just to know what is actually happening around us. So that you are not that person who is already kept in a shell, you know. You have to come out of the shell to know what's happening. And that is why statistics is important. Now let's go on to today's topic. Today's topic is based on probability and events. Nothing new for you. You've heard about events in your previous sessions as well, right? In your previous classes. Year 12, Year 11, Year 9, Year 10. Events were there. Do you remember independent events? Independent event, have you ever heard about it? Yes? How about dependent? Yes? Or no? Any other? I'm not going to ask you definitions now. It's just you saying yes or no. Be loud, don't worry, no one will judge you over here. You're new to this. Have you heard about mutually exclusive?
Yes.
Yes, you've heard about mutually exclusive. But it must be very blunt, right? You don't remember what it actually meant. Let's try to recall that. Since our school doesn't have proper projectors, or we don't have proper internet source so that I can actually show you using a projector, I would ask you people to come closer and I'll show you a short video clip on independent and dependent events, and you are to watch that and explain to me what you have understood. It is an animated video, so you can laugh over it, you can say, oh, this is interesting, that is not interesting, right? First, let's try to see whether you're able to recall or not after watching this video, right? Sorry students, we don't have a PowerPoint projector here, we're still poor. Okay.
Both independent events and dependent events.
Try to focus on what they're
Defined
saying.
with respect to probability. What are independent events? Independent events refer to the occurrence of one event not affecting the probability of another event. For example, let's say we are rolling a die and flipping a coin. Both of these are two separate events. We can say that the first event is rolling a die, and the second event is flipping a coin. Because the outcome of the first event does not affect the outcome of the second event, these events are said to be independent events. In other words, rolling a 6 doesn't increase or decrease the probability of a coin landing on heads or tails. The probability of getting heads is 0.5 and it stays that way regardless of what you roll. To calculate the probability of two independent events happening
Okay.
together,
So what examples was used to describe independent event?
Rolling a die and rolling and tossing a coin.
Tossing a coin and rolling a die. Now, what did you understand from here? Why is it independent? Let's take a coin, for instance. If I toss a coin, why is that independent? Why wouldn't it depend the other one?
Because the outcome of rolling a die is not affected by the outcome of tossing a coin.
Okay, yes, that's fine as well. What else? Let's just take a coin. If I toss a coin, there's only two probabilities. I can get a head, I can get a tail. Right? It's a die, remember, one die. So that means it's independent. If I get a head, it won't affect the tail. If I get a tail, it won't affect the head. And that is what is called by independent events. They are independent of each other. The word independent, what does the word independent means?
Free.
Free, okay? Free from one another, okay? That's a good way to describe independence. What else? Okay, you had an English class before this. I should go and ask your English teacher what she was teaching. Independent. Independent means you don't have to rely on someone. So similarly, head doesn't have to rely on tail, and tail doesn't have to rely on head. Right? Let's continue on with the video.
whether you can use this
Okay, no, there's an equation that has been given over there.
is equal to the probability of event A times the probability of event B. Let's do an example. If you roll a 6-sided die and flip a coin, what is the probability of rolling a 5 and getting heads?
Okay,
If
take out your book, where's your books, and try to write these examples down. It is basic introduction to probability, so don't get stressed out. We'll do it together. Write the questions down that has been given there. Independent events. Is it independent if I ate chocolate today and Michelle ate drank milk today? Is it independent event or dependent event?
Independent.
Why is it independent
underlying
Yes.
the environment.
Okay, good. There's no other questions, students. We'll see how the example works in. The question is, if you roll a six-sided die and flip a coin, what is the probability of rolling a 5 and getting heads? Interesting question. Thank you, I've written it down. Let's see how this works.
The first thing we should do is write down the formula. But in order to use
Okay,
this
so what is the formula there? How would you know what formula to use? Now, here comes union, intersection, and what is the other term? Two possible outcomes. Now, you are trying to know what is the two possible outcome, right? If you roll a die and roll a coin together, what is the possible outcome? You get that. You get this at the same time. So the formula that you're going to use is this. Probability of A intersection B. That is the equation. And after that, what do you get? You get find the probability of A times probability of B. Now what does it mean? Let's try to understand this equation. Right, this formula. This formula means that if you want to find out what is the income, then you are going to find the probability of one event first and then multiply it by the second event. Right? That is what the person is explaining. Now let's see ahead.
and the probabilities of each event. If you watched the previous video, you should know that the probability of an event is equal to the total number of favorable outcomes divided by the total number of possible outcomes. For the first event, there is only one favored outcome, which is rolling a 5, and there are a total of 6 possible outcomes since we are rolling 6-sided die. As a result, the probability of rolling a 5 is equal to 1 over 6.
Okay.
For
So when we talk about the probability, right? Probability of a die. Let's take a die. Normally, we'll have to see how many 5 are there, because we're trying to find how many 5s you can get, right? If you roll a die once, how many 5 can you get? You can get 5 once. When you roll it once, you get a 5 once. So the first outcome is that you get 1, that is not actually 1, but that is one outcome, that is 5. Right? Now, how many faces are there in a die? How many sides are there? 6. So this becomes a probability. The outcome you might get when you roll a die, right? This is the outcome. If I roll a die once, you get a 5. I'll get a 5 once, right? If I roll a die once, I'll get 5 once. If I roll a die once to get 4, I'll get 4. Or I won't get 4. So there is probability that I can get 4 once. Divided by 6, because there are 6 other faces that is present there. So there are 6 outcomes that I can get in total, right? But the probability of getting a 5 is just 1. So the answer, or the probability of a die getting 5 in one roll is going to be 1 over 6. Now let's try to figure out about a coin. Similar application to a coin, right?
For the second event, we know that the probability of getting heads is equal to 1 over 2, or 50%. And we know this because there's only one desired outcome.
Now let's try to figure out about a coin. Right? What is the probability of getting a head?
1 over 2.
Why 1 over 2?
If you can only get 1 in 1. Toss.
Yes, you can only get one head in one toss. It depends if you toss it twice or thrice, the numbers may vary, right? However, for coin, there is only two sides. So since there is just two sides, we have at the bottom the denominator as 2. The total outcome is 2. You have a head, you have a tail. But the probability of getting a head only will be 50%. Now you have found probability of A, probability of B. What happens next? Let's see.
which is getting heads. And there are a total of 2 possible outcomes, since the point can land on either heads or tails. Now that we have the probabilities for each event, we can use the formula. And all we have to do is multiply them together.
So now try to multiply it and get an answer quickly. Because you have to use this formula. Note this formula down. This is for independent events.
One over 12.
1 over 12. So your answer is 1 over 12 and 6.
X times 1 over 2 is an answer of 1 over 12.
Good.
As a result, the probability of rolling a 5 and getting heads is equal to 1 over 12 or 0.083.
Now I would advise always write your answer as a fraction. Mathematical answers are now since you're in year 13, you go up to your tertiary level, if you take engineering, if you take maths, depending on whatever course you take, always express your answers in fractions. Because if you write it as a decimal, you will round off. And that is not the exact value. So to get an exact value, always try to write it in terms of fractions. Clear on that?
Yes, madam.
Okay, great. What is the timeline? Right, it's almost time. Good, we have covered about independent events. Now, would you like to just quickly recap on that? What did we cover? How did you find this? Some answers from the room?
Multiply to
Probabilities.
probabilities.
Right, per minute. And what did we cover today? We have reintroduced ourselves to statistics. And why statistics important?
You can be aware of what's happening.
Very good, very good. And what's your homework tonight? Go back and watch the news and get me some statistical data from that news, either at 6 p.m. at MT1 or 7 p.m. at MT. Okay, there goes the siren. Thank you so much, class, for attending, and we'll cover the other types of events in our next class, which will be a full 50 minutes class. Okay, today it was just 20 minutes because of this assignment. Thank you, all the best.